In this video, we'll look at the area of special polygons. And let's start with a triangle. The formula for the area of a triangle is half of the base times the height. Please keep in mind the base and height are perpendicular. So for this yellow triangle, we can call the base 3 and the height can be 6. And let's do half of 18 or 9 square units. Area will always be labeled in square units. Let's look at another triangle. It is not overly obvious which side you want to call the base, which one you want to call the height here. But you want to look for a base and a height which are perpendicular to each other. So my base is going to be 14, my height is 6. And to make my computation easier, let's do half of 14 or 7 times 6. That's 42 square centimeters for that triangle. The formula for the area of a triangle is half of the base times the height. Let's move on to a rectangle. We have the area of a rectangle simply as length times width. This should be familiar to you, so we're just going to multiply 6 times 3 to get 18 square units. Let's look at this rectangle. Not as easy. We know the length, we don't know the width. We can call it x. I'm seeing a right triangle there, are you? So we can apply the Pythagorean theorem of a squared plus b squared equals c squared. And we can determine that x equals 6 centimeters. Now I know my length and my width, and substituting them into the formula, I get 48 square centimeters for the area of that rectangle. Next, we'll look at a square, which is a specialized kind of rectangle. The formula is simply area equals side to the second power. So to find the area of this first square, we're just going to square the number 8. We get 64 square units. If I were to count all those little unit squares inside of that figure, there would be 64 unit squares inside. The second square is what we can call a tilted square. It is not obvious what the side length measures, but I can construct a right triangle where the side length of the square is the hypotenuse of the triangle. It looks like a 3, 4, this would have to be 5 right triangle. I now know my side length is 5, so my area is 5 to the second power, or 25 square units. So the area of a square is just side to the second power. Let's look at a parallelogram. The formula for the area is base times height. And again, the base and height will be perpendicular. So you have 3 numbers, 3 measures in this parallelogram. Which one do you want to call the base? Which one do you want to call the height? And now we're going to multiply 2.5 times 1.8 to get 4.5 square meters. And that's easy enough. Area equals base times height. But when I have a parallelogram that looks like this, you have to be careful what you want to call the base. Let's find a side that's easy to measure. Let's call this the base. Therefore, the height is the perpendicular distance to that base. So my area is 2 times 4, or 8 square units. The area of a parallelogram is base times height. We'll move on to a trapezoid. The formula is a bit more complicated. A trapezoid, recall, is a quadrilateral with exactly one pair of parallel sides. The bases are the parallel sides, and the height is the distance between the bases. So the formula is half of the height times b1 plus b2. What we want to do is, when we see a trapezoid, identify the bases. Here are my bases. From there, you can identify the height, the distance between them. So my height is 2 units. It's the distance from A to B. And my 2 bases are B, C, and AD. So we'll substitute in the measures and we'll work out the math. We'll do half of 2 is 1, and 1 times 5 is 5 square units. Let's use this formula one more time, but this time I want you to identify the bases. I want you to identify the height, and I would like you to please substitute in those numbers into the formula. And then let's see if we agree on the area of this trapezoid. So my height is 9, my bases are 10 plus 18. I then work out the order of operations. I determine that half of 28 is 14, and 14 times 9 is 126 square meters. Okay, we're going to look at a rhombus next. This is a special kind of parallelogram. Recall the formula for the area of a parallelogram is base times height. Do you know what the base is here, and can you tell what the height is? So the base is 5, and the height, which is the perpendicular distance to the base, right? The height is 4. So the area is 20 square centimeters. There's another formula that's very useful for a rhombus, and it has to do with the fact that we might be given information about the diagonals. If we know information about the diagonals, we can use this formula for the area of a rhombus, half of the product of the two diagonals. So let's look at the diagonal from S to Q. We know that part of it is 4, so the other part would have to be 4, because in a parallelogram, the diagonals bisect each other. In the blue diagonal from R to P, the whole distance is given as 12. So we'll substitute in our numbers into our formula. And we'll do this time half of 12, which is 6, times 8 is 48 square centimeters. So this formula can be used not only for a rhombus, but also for a kite. The distance between the opposite vertices, we're calling that the diagonal. In a kite, the shorter diagonal is going to be bisected. So if the top piece is 5, the bottom piece is 5. We now have the information to substitute into the formula. We have half of 18 times 10, which is 9 times 10, or 90 square units. Okay, let's look at a kite that looks like this. We are missing some information here. We know that x would have to be 5 because the shorter diagonal is bisected. But the piece that's y is going to be a side of a right triangle. And I remember the Pythagorean triple 5, 12, 13, so y would have to equal 12. I now know my longer diagonal is 17, my shorter diagonal is 10, so I can substitute into the formula. We can do half of 10, which is 5, and 5 times 17 is 85 square units. Well, we talked about a lot of information in this video, so let's end by having you try to summarize and finding the area of these 4 figures.